Now, the concept of refrigeration and the refrigeration circuit can be difficult to grasp. And the goal of this video is to simplify this concept and look at refrigerant flow through a basic AC system. Now, there's all sorts of different refrigerants on the market, and each refrigerant was created for a specific function. So refrigerants that are used to cool the walk-in freezer at your favorite restaurant will be different than the refrigerant used to cool your home. And selecting the right refrigerant for the job is up to the design engineers. And they're going to set a stamp on the data plate showing which refrigerant should be used in that system. So for simplistic terms, think of refrigerant as something that can transfer heat in a liquid and vapor form. And it is this transition between liquid and vapor where the heat transfer really occurs. So it may be easiest to think about refrigerant, in this example, in a can of compressed gas. And these can be found at any office supply store to blow dust from your computer keypad. Now 152A boils at -13 degrees. So this can has a lot of pressure when it's sitting in a room at 75 degrees. Enough pressure to clean my keyboard. And there's all sorts of warnings on this can. Do not shake. Do not turn upside down and spray. And the concern is spraying liquid refrigerant out of the can. And if that liquid refrigerant leaves this can, it evaporates very quickly. And that liquid evaporization is going to extract a lot of heat from whatever it touches. And it can cause some mild skin irritation or frostbite, all depending on the amount of liquid that hits the skin. Now R22 boils around -40 degrees, and R410A around -60. You'll always want to wear gloves when removing refrigerant gauges from these systems. So let's pick a warm day. Let's say it's 95 degrees outside and 75 degrees inside the house. The AC is running, and we're going to start this analysis at the compressor. And the compressor is often referred to as the heart of the system. Now the goal of the compressor is simple. It compresses vapor refrigerant. And the animation here of a scroll compressor, you can see the vapor refrigerant, that's probably around 120 pounds of pressure, is entering through that large outside ring of the scroll plates. And as the refrigerant flows through the plates and towards that smaller center area within the scroll, the refrigerant becomes more and more compressed, and it exits the compressor, probably close to 400 pounds of pressure in our example here. And this increased pressure correlates to an increase in temperature. And that small discharge line that leaves the compressor not only carries the heat of compression, but also the heat of the compressor itself. And that discharge line that is leaving the compressor will typically be between 60 and 70 degrees warmer than ambient. So this discharge line will be around 120 degrees. The refrigerant leaves that compressor in a hot, superheated condition, and the fan that is moving that cooler 95-degree air across the coil fins and the refrigerant starts to cool quickly. And then it transitions from that vapor to the liquid state, which is where most of the BTU transfer occurs. And that liquid refrigerant continues to cool a little, and it leaves the coil in the liquid line, which is that smaller line, moving towards the indoor coil. Now when that liquid refrigerant reaches the indoor coil, it hits the expansion valve. And the goal of the expansion valve is to meter the refrigerant. And it delivers a controlled pressure drop that is similar to holding that can of that dust spray upside down. But unlike that can that drops the pressure all the way down to 0 psi, the metering device is going to drop that liquid pressure to around 125 psi. And this may vary a little bit, all depending on the indoor load. And the goal of the expansion valve is to maintain an indoor coil temperature that is most typically between 40 and 45 degrees. Now the indoor motor is moving that room air temperature, it's about 75 degrees, across that cold coil. And that coil is absorbing heat from that air. And this absorption of heat causes the refrigerant to transition from that liquid back to that vapor form. And when the refrigerant leaves the coil, it should be pure vapor with a temperature typically between 50 and 65 degrees. Now this cool refrigerant is going to make it all the way back to the outdoor unit through that large insulated vapor line, sometimes referred to as the suction line. And the cool refrigerant reaches the outdoor unit and feeds back to the compressor, keeping that compressor nice and cool. The refrigerant is going to work its way back into the scroll plates again, and it's going to become compressed to run another cycle through the refrigerant system, keeping that homeowner nice and comfortable.